Folks, this is Mr. V, and I'm making this recording to help you get through today's lesson on completing the square. And we're actually going to do the formal lesson from Illustrative Mathematics tomorrow. But today we're doing some practices, which the idea is to say I can complete the square, which is to make a perfect square trinomial out of the square of a binomial. And these exercises will take you through it. I'm going to walk you through each one of them just to make sure that you are up with me. X times x is x squared. That's one way of looking at the area of this. We have a length times width. Here we have a length times width. 1 times x is x. And when you see that, here we have the green rectangle had an area of x. The blue rectangle has an area of x squared. What's the area of this new rectangle? It would be x squared plus 2x. Now, the algebra tiles that we're going to use for this lesson, we have an x squared block, which is this blue one, an x block, which is 1 times x, and then a unit block, which is 1. So when we combine it, it looks like this. We have an x plus 3 times x plus 3. That's going to give me an x squared, 6 x blocks, and 9 unit blocks. Okay. The area of this rectangle has an area of x squared plus 6x. Using the red point, make another polygon that has the same area. Now, if I did it like this, this would be a rectangle. We want it to be not a rectangle. It needs to have plus 6x. So if I do 4 plus 2, I could do it like this, 3 plus 3. I can't do this. This is not the same area. It's got to have 6x blocks and 1 x squared block. How many would this need to make this into a square? If I'm going to make it like this, make it into a square, how many x blocks would you need to add? Well, there's 3, 3, and 3 would be 9. And if you got this wrong, maybe you made your rectangle too big. It needs to be 6 x blocks. That's 6 of these green ones. And it needs to be a square. Okay. How can we do this? We can add these together and put these all in. And you end up with x squared plus 4x. So I'll type that in. X squared plus 4x. And you put all these together. The bottom right, how many x's are missing? If I type in too many, like 9, for instance, I'm going to get a block that doesn't fit. That's not quite right. And of course, we all can look at this and say, oh, that's 4. Sure. And what's the area of the x blocks? The red ones are x blocks. That's 4x. And the blue ones, x squared. And can you see that this is a perfect square, because over here is a square, trinomial. And this is what it would look like. Perfect square trinomial. This could also be represented as x plus 2 times x plus 2, which is the square of a binomial. So we have two different ways of looking at the same thing. And now we can put in the pieces. We can see how much extra is going to be left over when we put in this 4 by 4 block. It should be a 3 by 3 to make it a perfect square trinomial. We're going to have some left over. So we're going to have to check it out. Let's see how much we got. I'm trying to move this with my mouse. And this is a self-pacing activity. It has, so the green one's going to be too big. How much too big is it? It's going to be 7. I'll have 7 units left over because I have a 3 by 3, that's 9. 4 by 4 is 16. 16 minus 9 is 7. And this is what it would look like. So if I make this 7 units long, 7 units is how much is going to be not within the dashed lines. This is what it looks like algebraically. I have this square binomial, and I'm adding 7x to it. How would you be able to write this in vertex form? I mean, the vertex form is like this. How would you write it in standard form? Let's just look at the things on this left and put them down. We have 7. I have x squared plus there's 6x blocks, and then there's going to be 16. And if you do this incorrectly, the graph on this next page would not match up. I show you the solution, and I show you your solution. If it matches, like for instance, if I put in, say, 15 here instead of 16, then when you submit it, it's not going to match up. So you need to make it match up. It's self-correcting. That's what self-checking is for this whole unit here. What's the area of this square? Well, there's two ways of writing it. You could write it in expanded form, where you take the x squared, the 6 green blocks, and the 9 extras. Or you could write it x plus 3 times x plus 3. So this would be the factored form, the square of a binomial. This is a perfect square trinomial. So if we do this one, how many blocks would we need to complete the square? Well, let's make it into a square. We want it to be 10 x blocks, 10 of the green ones. I'm going to have to add 25 to both sides. And that's the same as x plus 5 times x plus 5. Here, to make this 8, I want it to be a square, I'm going to have to add 64. All right, 64. No, I'm going to add 16. And that's going to be x plus 4 times x plus 4. To make this x plus 12, I need to have 6 on both sides to make it a square. And what are we getting? And if it's equal to 64, then I have to change both sides of the equation. So what am I adding to this? Well, there's 6 times 6 is 36, and this would be 64 plus 36. So I could say x times 6 squared, 36 plus 64 plus 36. If I do this, it's equal to 100. Then I have, this is 6, and this would be 10 squared. And you'll see why this is important later. Mariah says that this is equal to this. These are equivalent. Well, let's just check this out and see. I'll copy this over to my whiteboard. We'll expand it and see if it's the truth. When we expand the second term, we're going to use the box or the area model. X plus 3 times x plus 3. This is x squared. 3 times 3 is 9. 3x and 3x. And when you add the 3x's, which are like terms, you get 6x. These are the same. Yes, they are. Why? Because we multiplied out, we expanded this one to see that they are the same. Now, you've been doing this process called completing the square. So we use this to turn a quadratic into from standard form into vertex form or factored form. And so you can choose any numbers you'd like. Let's say you can choose 6, and if I choose 9, that would be 0, because I can see that this was going to be a negative 9. I could choose 12, in which case this would be a positive number, or I could choose 6, and this would be a negative number. Just go with this 6 and 6. Now, the equation shows x plus 3 squared minus 3. So I'm going to write it in vertex form. I would say x plus 3 squared, and then minus 3. And that's going to give me the same thing. And if we see it is correct, it'll match up on the graph. That's what we want to do. So when you solve this one, this is the reason we do this, completing the square, is to solve an equation. And how would you solve it? Here's how we go about solving it. We take this, and we take the square root of both sides. When you take the square root of the left side, you get x plus 3 squared. Take the square root, that's the inverse operation. You end up with x plus 3. When you take the square root of 25, you have to take a plus or a minus. So this is equal to a plus 25, or x plus 3 is equal to a minus 25. In which case, if I subtract 3 from both sides here, I get x is equal to 22. I'm sorry, 25. What am I thinking? That should be 5, plus or minus 5. So, excuse me. So 5 or a negative 5. So if I subtract 3 from both sides here, I get 2. Or if I subtract 3 from here, I get a negative 8. So when we plug that into the Desmos, we plug in 2. And yes, great, there's another answer. Let's see, that would be negative 8, because it's a plus or minus. It's a curve. It goes across that line twice. That's why. Here again, you get to choose your answers. We need to come up with 3 equations. So if I do 6 and 6, this would be a negative. So I'm going to type over this equation. I have y equals 3 squared minus 3. If I change this to 9, I think that's what, if it's 0, 9 minus 9, if I add 9, it would be 0. So I have y is equal to x plus 3, x plus 3 squared. And then if I make this number less than, like say, negative 8, say 8, well, that's a negative. I'm going to make it 6 and say 12. That's a positive 3. So I have y is equal to x plus 3 squared plus 3. These 3 equations. One has where I'm adding 0 to it, one I'm adding a negative number, and one I'm adding a positive. And when we look at the graphs of these 3 things, which one would give us no roots? That is, where it doesn't cross the x-axis at all. That would be the purple one. And the reason it doesn't have any roots, the roots are where the y value is 0. So what is x when y is 0? And here we have 1 place. We have 2 places. We have no places. So you can have 1 root, no roots, or 2 roots. This explains it more in detail in writing. And on our equation, if we were to solve this for the roots, let's do this. I'll copy this over to my whiteboard and we'll solve this. We're going to solve this for the roots, or for where the y value is 0. So we'll start by setting y equal to 0. We'll add 3 to both sides of the equation. And we get 3 is equal to x plus 3 squared. To do the inverse operation, I'll take the square root. I'll take the square root of this side, which means it's going to be a plus or a minus. When you take the square root from the next squared here, you're going to get a plus or a minus. So x plus 3 is equal to plus or minus the square root of 3. I'll subtract 3 from both sides. I get x is equal to negative 3 plus the square root of 3, or x is equal to negative 3 minus the square root of 3. And we can plug those values into this Desmos. I have negative 3 plus square root of 3. There's where it is on the dot on the graph, or negative 3 minus the square root of 3. And there it is. And there's some other activities like this for you to try out. Here's another one that you can try out, and a written explanation of what's going on. Now, like this activity, I'm going to go through one of these with you to show you what's going on. If I have 4x, I want to make this into a perfect square trinomial. So the expanded form of this expanded square equation is going to be x squared, and I'm going to have plus 4x plus 4. The active form would be x plus 2 squared. And what is this when we solve this for x? What do we get when we solve this for x? So I'm going to show you this on my whiteboard again. And there will be several exercises that you can actually try with this. I want to make this a perfect square trinomial. So I'm going to remember I had to add 4 to make this the perfect square. So I'm going to add 4 to both sides of this equation. Now I get x squared plus 4x plus 4, which in factored form is x plus 2 squared. That's going to equal to 16. Now to solve this, we'll take the square root of both sides of the equation, and this will be a plus or a minus. So I have a plus or a minus of 4 is equal to x plus 2. X, when I subtract 2 from both sides, I get 4 minus 2 is 2, or x is equal to a negative 2 plus a negative 4, which is a negative 6. So it could be either one of these as my answer. And I'll plug both of those into this equation. So it says here it could be 4 2, and that's good. Or I could have put in -6. That's also good. I'm sure it doesn't work if I put in -5. It's going to say, no, not good. Try again. And there are some other questions for you to answer this. I'm just going to stop this right here, though. I'd like you to try this on your own. Tomorrow, we're going to actually do the illustrative mathematics activity on completing the square. Good luck and success.